and this table that is shown here. So we have two angles which are shown here, alpha and theta, and theta is also this angle that is shown here in this unit circle. And let us assume for the time being that theta is an acute angle, that is, it is between 0 and pi by 2. And we have 6 scenarios here in which alpha is expressed in terms of theta in different ways. So for example, in scenario 1, alpha is pi by 2 minus theta. So therefore alpha would lie somewhere in the first quadrant. In scenario 2, alpha is pi by 2 plus theta, so obviously it would lie somewhere in the second quadrant. In the third scenario, alpha is pi minus theta, which would again place alpha in the second quadrant. In the fourth scenario, alpha is pi plus theta, which would mean that alpha would lie somewhere in the third quadrant. Fifth scenario is alpha is equal to 2 pi minus theta, which means alpha is somewhere in the fourth quadrant. And in the last scenario, alpha is minus theta, which we have earlier seen is equivalent to 2 pi minus theta. So therefore again alpha is somewhere in the fourth quadrant. Let us now draw rough sketches of these possible values of alpha. So when alpha is equal to pi by 2 minus theta, it would look something like this, where this particular angle is alpha and this is theta. And when alpha is pi by 2 plus theta, it would look something like this. When alpha is pi minus theta, it might look something like this. When it is pi plus theta, it might look something like this. And when it is 2 pi minus theta, it would look something like this, which is also what it would look when alpha is minus theta. And in each of these cases, these small angles are equal to theta. All of these angles are equal to theta. Now for each of these cases, let us express cos alpha, sin alpha, etc. in terms of theta. When alpha is equal to pi by 2 minus theta, it is the angle that this line segment OR out here makes with the positive x-axis in the counterclockwise direction, right? And cos of alpha is therefore the projection of line segment OR on the x-axis. So something like this. And by symmetry, we can see that the projection of OR on the x-axis is same as the projection of this line OP on the y-axis. Now since OP makes an angle of theta with the positive x-axis, therefore its projection on the y-axis is sine theta. And we know that projection of segment OR on the x-axis is also on the positive side. So therefore we can say that cos alpha is equal to plus sine theta, right? And how about sine alpha? Sine alpha is the projection of line segment OR on the y-axis, which by symmetry we can see is same as the projection of line segment OP on the x-axis. And since both are positive, we can say that sine alpha is equal to cos theta. Now when alpha is equal to pi by 2 plus theta, that is the angle which this line segment OS makes with the positive x-axis in the counterclockwise direction. And we can now see that cos alpha would be the projection of OS on the x-axis, which is somewhat here, but on the negative side. And in magnitude, we can see that it is equal to the projection of OP on the y-axis. Therefore, we can say that cos alpha is equal to minus sine theta. And sine alpha is the projection of line segment OS on the y-axis, something like this, which is positive. And in magnitude, it is equal to the projection of OP on the x-axis, which is cos theta, which is also positive. Therefore, we can write sine alpha as equal to cos theta in this case. Now, when alpha is equal to pi minus theta, it corresponds to the angle that this line segment OT makes with the positive x-axis. And we can see that line segment OT is the mirror image of line segment OP around this y-axis, and therefore the projection of OT on the x-axis, which is cos alpha here, is on the negative side, but its absolute value is equal to the projection of line segment OP on the x-axis, which is on the positive side. Therefore, we could say that cos alpha here is equal to minus cos theta, and likewise sin alpha is the projection of line segment OT on the y-axis, which is on the positive side, and its absolute value is same as the projection of line segment OP on the y-axis, which is also positive. Therefore, we can say that sin alpha is equal to plus sin theta. Moving on, we see that pi plus theta is the angle that this line segment OU makes with the positive x-axis in the counterclockwise direction, this particular angle out here. And we can see that the projection of OU on the x-axis is cos alpha, which is on the negative side, whose magnitude is same as the projection of OP on the x-axis. Therefore, we can write cos alpha as minus cos theta. And likewise, sin alpha is the projection of OU on y-axis, which is again on the negative side, and its magnitude is same as the projection of OP on the y-axis, which is on the positive side. Therefore, we can write sin alpha as minus cos theta. Now, this angle 2 pi minus theta is what this line segment OV makes with the positive direction of x-axis, something like this. And here we can see that OV is the mirror image of OP around the x-axis. Therefore, cos alpha here is equal to plus cos theta, because the projection of OV on the x-axis is positive and its magnitude is same as the projection of OP on the x-axis, which is also positive, whereas sin alpha is minus sin theta, because the projection of OV we can see is on the y-axis is on the negative side, and its magnitude is same as the projection of OP on the y-axis, which is positive. And finally, when alpha is equal to minus theta, it is same as the angle 2 pi minus theta. It is this angle that OV makes from the positive x-axis in the clockwise direction, and therefore cos alpha here would be same as that in the case of 2 pi minus theta, that is cos theta, and sin alpha would be same as minus sin theta. Now we can easily fill the rest of the table. Let us do that. Tan alpha is equal to sin alpha by cos alpha. Therefore, when alpha is equal to pi by 2 minus theta, we can see that tan alpha is equal to cos theta by sin theta, which is nothing but cot theta. When alpha is equal to pi by 2 plus theta, it is cos theta minus sin theta, which is minus cot theta. When alpha is equal to pi minus theta, tan alpha is equal to sin theta by minus cos theta, which is minus tan theta. Now, when alpha is equal to pi plus theta, now here we made a mistake. I'll just correct that. Here, when alpha is equal to pi plus theta, sin alpha should have been minus sin theta and not minus cos alpha. So therefore, tan alpha here is equal to minus sin theta minus divided by minus cos theta, which is plus tan theta. And likewise, when alpha is equal to 2 pi minus theta, then tan alpha is equal to minus sin theta divided by plus cos theta, which is minus tan theta. And when alpha is minus theta, tan alpha is again minus tan theta. Now let us look at sec alpha. Now we know that sec alpha is equal to minus cos alpha, so therefore we will compare these two rows. When alpha is equal to pi by 2 minus theta, sec alpha is equal to 1 by sin theta, which is cosec theta. When alpha is pi by 2 plus theta, sec theta is equal to minus cosec theta. Here it is minus sec theta, again minus sec theta. Here it would be plus sec theta, and again plus sec theta. And cosec alpha when alpha is equal to pi by 2 minus theta is 1 by sine alpha, which is 1 by cos alpha, which is 1 by cos theta, which is sec theta. Here again it is sec theta. Here we are basically comparing these two rows. Here it is cosec theta minus cosec theta. Once again minus cosec theta and minus cosec theta. And cot alpha we know is 1 by tan alpha. So here it would be 1 by cot theta, which is tan theta. Here it's 1 by minus cot theta, which is minus tan theta. Here it's 1 by minus tan theta, which is minus cot theta. Here it's 1 by tan theta, which is cot theta. Once again 1 by minus tan theta, so minus cot theta. And once again here we have minus cot theta when alpha is equal to minus theta. So we have this beautiful table, and it's very important to know these relationships.